Guys, so today we are going to discuss about a statistics question. So this is the question from our friend and we are going to discuss it together. Okay, so as you can see, this is a statistic question, and let's begin to read the question without further ado. So in the women a single badminton match, okay, the first player wins 2 out of 3. So the condition is to win 2, okay, out of 3 sets to win the match. Okay, the probability of particular player winning a set is 0.7 if she wins the previous set. Hence, the probability of winning, if she lost, then it's supposed to be 0.4. We are required to draw a tree diagram. So let's finish the first question first to draw the tree diagram. Okay. In order to draw the tree diagram, we need to consider each set. Okay, so first is set 1. Okay, like this. Set 1. Okay, and then we have win and loss. Okay, win and loss, like that. Okay, so first set, win or loss. Okay, you need to be careful because 0.7 is the probability of winning if. So there is a conditional word there, which is if she wins the previous set. But for the set 1, we don't have the previous set because this is the very first set. So we can assume that the probability of the winning first set is equal with the probability of the losing the first set, which is 1/2. Okay, so they are equal probability. Okay, this is the set 1. Set 1, I will circle it like that. And set 2, you will have win or loss, win or loss also. Okay. Win, loss, win, loss. Okay, because for the first condition, she wins the first set, which means the probability of winning, of course, to be 0.7 because according to the question, right? 0.7. 0.7, and then we circle it like that, and then the losing probability will be the remaining, which is 0.3. Okay, and then for the second blank over here, for the second cast there, we need to fill the two blanks. Okay, the empty blanks. So because she lost, okay, the first set, then which means the probability of winning the second set will be 0.4, right? Because the question said that the winning probability is 0.4 if she lost the previous set. So the previous set is set 1, so it will have 0.4 probability. The remaining is the losing probability, which is 0.6, like that. So this is for the case of set 2. Oops. Okay, like that. So this is set 2, and then let's consider set 3 because we have 3 sets. Okay, you don't have to. Okay, let's do like this. So win. Okay, wait. So this is winning. Okay, so winning, so you don't have to consider this because both of the sets already win. So of course she will be totally win, so you don't have to do something here. So it's a nil or a blank. So the probability of losing, because she wins the previous set, which is set 2, then she will have 0.4, right, probability of winning. Okay, 0.4, sorry, 0. Wait. Oh, sorry. I'm confused. So we don't have to consider this because she already wins the first and second set. Sorry. So you need to have considered this and that. Okay, win or lose. Okay, so this is nil. Okay, and then okay, because she wins the previous she lose the previous set, so the probability of winning will be 0.4, will be lower than 0.5. Okay, then the probability of losing is 0.6, but you don't have to consider this also because she already lose two times, 1 2, which means she lose. Okay, she lost the game, so you don't have to consider that also, but it's okay, we'll just write it. And then the second one is this, sorry. Okay, so win, lose. Okay, so she already lose one times in set 1, so she must win the third match, the third sets, so that she wins the overall game. So because previous set 2 she wins the game, so the probability of winning supposed to be 0.7. Okay, 0.7. Then the remaining is 0.3, but it doesn't matter because you don't have to consider if she wins the game. Okay, so and then the last branch you don't have to consider because she already lose the game, so nothing's to do, right? So okay, the first question is to find the probability that players wins the match given that she lost the first set. So she lost the first set is this branch, so she lost over there, she lost, but she wins overall game, which is this way. Okay, so that way, let me reduce the transparency so that you can see this one, this path, and that path. Okay, so you cannot take the second path, which is this. Okay, this and that. Why? Because this is sorry, you cannot take this path 1 2 and 3, this path, because she only wins one times, which means she lost the game. Okay, so because the question wants the probability of winning, so you need to take the this path or this branch. Okay, because she is winning, then that path, okay, whatever value you see along that path, you just multiply it, so it's 1/2. So probability of winning is 1/2 times 0.4, so I see it 0.4 times 0.7. Oops, 0.7. And then this equivalents to, let me find my calculator first. So I got 0.14 as the answer. Okay, so the next question is, let me write it, AI. So if the probability that the player wins the match is 0.64, find the probability that she wins the first set. So this next question is, we do not assume that the winning and losing probability in the set 1 is the same. Okay, which means that the probability of winning is not 1/2. Okay, because in the first question we have to assume it is 1/2, equally and likely of winning and losing, because the question doesn't give the hint in the question, so we can assume it basically. But because the second question, it gives you the hint, which is the probability of winning the overall match is 0.64, then we can do something with it. Okay, so that's how we figure out the answer. Okay, so for the second question, we cannot assume it to be 0.5 of the winning and losing set. Okay, in the first winning and losing in the first set. Okay, so set 3, so this is set 3 basically. So I will copy this, okay, because it is almost the same. So for the second one, I will just paste. Okay, what I am required to change is wait. Okay, so I just need to change this a little bit, which is we assume that the probability of winning is x. Okay, we assume that the probability of winning is x. Then the probability of losing in the first set is 1 minus x. 1 minus x, okay? So 1 minus x, okay? 1 minus x. Like that. Cool. Okay, because she wins the game, the badminton match, so we have several branch to consider. I mean several case to consider. So first, if she wins here, wins there, then she will wins the overall game. Okay. Okay, so that's the first case to win. So let's mark this. And then also, when you win the first set, and suddenly you lose, and then you suddenly win, so you will win also. And then if you lose 2 times over here, sorry, this branch. So look, if you win the first, lose second and third set, then you will lose basically. So you don't have to consider that. Okay. And then if you first lose and then you win, then it will be considered to be winning. So you have 3 cases of winning. So these 3 cases you need to add up. Okay, so let's multiply this. So first is you win, probability is x. Then second is you win also, so 0.7. Okay, plus you win and then you suddenly lose 0.3. And then you win 0.4, 0.4, okay, and then plus you suddenly lose, and then you suddenly lose, which is this one, this case, okay, this one you lose suddenly, so which is 1 minus x, and then you win the second set, which is 0.4. Okay, and then you win again, which is 0.7. Okay, this equivalent to 0.64, right? And then you just solve for the x. Okay, after you solve for the x, you will get x equals to 0.67, if I'm not mistaken. So x is the probability of winning the first set. Alright, so it's very easy. Okay, just solve for the value of x over there. Okay. Alright, so question B is conditional probability. So it's also very easy. So let me copy paste back the answer, the question. Okay, so let's focus on the question B. So event x and y are such that px is that, py is that, and p probability of x given y is 3 over 4. Find the probability that. So you need to know that the formula for conditional probability, or the Bayes theorem, is p x given y is p x intersection y divided by py. Okay, and then the second alternative question equation is if I'm not mistaken is py probability y given x divided by probability of y. Sorry, this is probability of x, right? Like that. So this is the alternative expression, I could say, but we are going to use the second equation there, okay, to equate the given probability, which is 3 over 4. So we know that px given y, probability x given y, is 3 over 4 in the given by the question itself. 3 over 4 is So probability of x intersection y, we do not know. Probability of y is 1/2. So probability of p intersection y is 3/4 times 1/2 is 3/8. Okay, so this means that the event x and y is not mutually exclusive, so they have the intersection in the middle. Okay, which means that like it's like this. So this is x and y, so the intersection at the middle is have the probability of 3/8. So this is the case for the not mutually exclusive event, so I shorten it to be NMEE. For the case of mutually exclusive, it will be like this. So there is no intersection, so this is for the case of mutually exclusive event. So because our result is this, okay, the intersection exists, hence the event is x and y are not mutually exclusive event. Okay, so you need to write the long sentence lah for this. Okay, because I'm just shorten it with this acronym. Okay, NMEE, not mutually exclusive event, right, to save times. Okay, so the second one is to find the both events do not occur. So because we know that not occur, then you need to find the probability of x x or x union y. So for the case of not mutually exclusive event, the formula for this is p x, probability of x, plus probability of y minus probability of the intersection. Okay, so px is given by 4/7 plus py is half minus the intersection is, we just find 3/8. Okay, so this will gives you what? 4/7 plus half minus 3/8. How much is that? 39. Okay, it will be 39/56. Okay, so this is the whole event, which means x and y, the whole probability of this event, which means we include the whole this. So if both of them are not occurring, which means we need to minus with the total probability, which is 1. Okay, so the expression is like this: x union y not, which is 1 minus 39/56, which is 1 minus that is 17/56. Okay, that. Okay, the last one is B1. Only one of the event occurs, so this is easy. So only one occur, so we know that the intersection is 3/8. And then we want to find so this is x and y, so we want to find probability of x only. So x only is the probability of the whole x, so the whole x is defined as this is the whole x, and the whole y is this probability. Okay, so this is the whole y including the intersection. Okay, so we want to find only this part. Okay, only this part, and then we want to find only this part. only this part, so we doesn't include the in the middle. So what we can do is to minus from the whole part of x and y, which is 4/7 and 1/2 respectively. Oopsie. So 4/7 minus 3/8. So this is in the middle, or the intersection part. We have 11/56. And then we do the same thing to find the p probability of y only, which is the whole y is 1/2, and then in the middle is 3/8. So when I say in the middle is the intersection one, which is this part. Okay, 3/8. So we'll get the result 0.5 minus 3/8 will be 1/8. Then we just plus this. So p one of them will be 11/56 plus 1/8, and then we get the answer to be what? Right, so I think that's all for now. I need to end the video, and good luck. Thank you.